Hi. So in the last video, we discussed basic featureization of time and how we can write the same in the files. We discussed that. Now in the current video, we will be seeing some other exploring techniques with which we can understand the data more in a better way. So if you observe carefully in the original data without a time featureization, we can see that there are only two columns that has numeric values or floating values. Let's just take that and apply describe method of pandas just to get some sense the mean of each and the maximum, the minimum, all that stuff. So I'm doing this describe method for training data. The count of the entire data set is 8,78,000. The mean of latitude is 37. The mean of longitude is minus 122. The main coordinates of San Francisco are 37.77 latitude minus 122.41 longitude. So these are the main coordinates of San Francisco. And these percentiles all should belong to that should be in that same range. So here 75th percentile is 37.78 and of latitude and minus 122.40 of longitude. So the 75th percentile is in the same range of these coordinates. But if we see the maximum value of latitude, it is showing 90, which makes no sense. Similarly, for longitude, it is minus 120. So clearly there has to be some mistake while entering these points. This we can observe in the training data. Similarly, in the test data, we get to see the same stuff. Maximum point to be 90 of latitude and minus 120 of longitude. Clearly, there has to be some mistake. And coming to distributions. So clearly, this category column is a class label uh, that we want to predict, right? While after training the data. So let's just check the distribution of each categorical column. For doing so, we will use this function. I'm using Plotly here to visualize, to get the interactive visualization, Plotly Express basically. So here I pass the data set, data frame, and the column which I want to visualize a distribution. Okay, so once I get the column, I can get the unique values of that with respect to the count of each, right? I can convert that into frame and reset the index. This is the pandas technique to, uh, do some programming hacks. Once I get this, I can change the columns. So I recommend you to, while you are practicing, I recommend you to print the values before executing so that you will learn in a better way. Once we have this, we can create a figure object by passing the column val df as our data frame, x axis to be the column and y axis to be the count that we are giving here. Now we can update the layout, basically setting the figure layout. Height should be 600 and width should be automatically resized. And the legend part, the margin part, these are just the techniques, arguments that we can, make the layout more appealing. Once we update the layout, we can finally show the plot. Figure.show is to show the plot and return none. So let me use this column by passing my train data set along with the category as column. So if I execute this, I get to see this interactive plot. So these are my class labels, and these are the counts of each class label. So this part where I have this class label, it is appearing very less less number of times during the entire 12 years of time. It appeared not less than 3 times. And similarly, here we have latency theft, which appeared more than 174,000 during these 12 years. So this with this we can observe that this is highly imbalanced. This we cannot, in this case we cannot use accuracy as metric. We can use accuracy only when we have balanced data. In this case, we cannot use that. This gives us some overall idea how the class labels are repeating, and how we can go with our approach. So that's about category. Similarly, we can check the distribution for address type. So here we see that the streets are repeating more often, and the next repeating value is cross. Likewise, we have other street types, the address types. And yeah, that is something we can observe. Another thing we can do is get the distribution for police department column by just passing the column name there. And here we see, let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there are 10 districts, and Southern is the district that has the highest repetition. Richmond has a less repetition, and this has been captured by considering the whole data set that happened to be 12 years of data. Similarly, we can pass year distribution, year column distribution, and it is almost a uniform distribution. But the only thing is 2015 is very less. One thing I forgot to tell you is that 2015 they only captured till yeah, I think till 5th month they captured the data, and later on they stopped capturing. Yeah, the data of year 2015 is not recorded fully, but rest of the years we get to see similar distribution. 2013 has highest count. Similarly, for month we can check the distribution. For weekday we can check the distribution. It almost has a uniform distribution. And hour, we can see slightly difference in this. It's because most of the crimes they usually happen either in midnight or evenings or night. So during this time, during this hour, it's mostly we can say early morning, or we can think of it as a business hour. And rest of the hours we get to see the highest frequency of the crimes happening. Similarly, we get to see the minute distribution, season distribution. Although this column, seasonal distribution, does not add value, but still we get to see that most of the crimes happen in summer season. But we still, this is almost uniform. So we can't comment on that part. Coming to time period, PM is a time period where crimes happen usually. It's mostly evening times and night times. AM, we get to see very less count. Hour type distribution, morning, in the sense after 4, we get to see some crimes happening that time, and the next thing is midnight. Noon is a time hour type where very less crimes happen. Again, it's mostly because of business hour and other reasons. That's about this column distributions. Next thing is animations. So this class is basically coming from a visualizer file, and this basically helps us understand the distribution with respect to the class label in certain year and in certain department. So here I get to see these buttons, uh, play and pause, and here I have years as in the slider range, and starting one is 2003, and we get to see the occurrence, the repetition of this crime category. Uh, Arson is occurring 17 times in this 2003 year. Likewise, we get to see the distribution count basically with respect to each category. Let me play it for you. And you see the movement. Most of the time, it's either latency theft that happens to be the highest, uh, that has highest count. We can also uh, play with this by moving it here and there, and that gives us a whole idea about the count of each crime. This argument is nothing but filtration technique. Only it only takes a southern district and gets the count of the crimes. So this we are doing yearly, right? Similarly, if you want to do monthly, we need to pass year as a filtration part, and we can also pass department of the police. So same stuff, but monthly it goes. So we have 12 months in the year, in every year. So we can change the year there, and it works as usual. Likewise, we can also get the count on daily basis. For getting the count on daily basis, we must pass year, month, and department. It is optional. So yeah, the same stuff repeats. Likewise, we can also do hourly, but I just commented it. If you're doing it, you can please uncomment and execute. It's up to you. That's it for this video. Let us meet again in the next video with other visualization uh, plots. All right.